Hello and welcome back. I should say if I'm becoming lighter and lighter, that is because the sun is rising here on the west coast of America and I'm slowly being lit by it. There isn't anything strange going on. But anyway, welcome back, as I say. And without further ado, let's move on to our next headliner. So aligned with our theme of Without Borders, our next speaker will be sharing how AI tools can help communities to make smarter investments and to build wealth, and particularly on how they can benefit the less wealthy and underserved communities. He directs MIT's Human Dynamics Laboratory and the MIT Media Lab Entrepreneurship Program. He co-leads the World Economic Forum Big Data and Personal Data initiatives, and is a founding member of advisory boards for Nissan, Motorola Mobility, Telefonica, and a variety of other startup firms. If that wasn't enough, he's also on the board of the UN Foundation's Global Partnership for Sustainable Development Data, co-led the World Economic Forum discussion in Davos that led to the EU privacy regulation, GDPR, and was central in forging the transparency and accountability mechanisms in the UN's Sustainable Development Goals. So, without further ado, please give a hugely warm welcome to Alex Pentland, who is better known as Sandy Pentland, that's what everyone calls him, with a presentation entitled Extended Intelligence AI for the New Economy. Welcome, Alex. Welcome, Sandy.
Thank you. Thank you. So glad to be here. Hope people are going to be interested in this and have further contact, and let's make things happen. So that's a little cartoon of me, and I'm sponsored at MIT by a variety of large organizations, multinational, often in the financial area, but sometimes in other areas like telecoms, and work, as she was saying, with many different organizations around the world. And what we do is a lot of things, because we're not just in the Media Lab, we're also in the School of Engineering, the Business School. In the Media Lab, we develop new ways to use data safely. So following on from GDPR, we're involved in ways of doing federated AI, doing privacy-preserving AI, and things like that. And we work with the UN and the EU to do this. In the School of Engineering, in the Sloan School, the Business School, we work on the economics of data and regulation. So just the technology is not enough. You have to also think about, what are the incentives people have? How do you control those and yet get a prosperous world? And in the College of Computing, what we actually do is develop open source pre-standard software. So our group extends back more than 20 years. We developed Kerberos, which handles 85% of all the authentication on the web today. We were also co-chairs for OpenID Connect, which is the sort of next-gen authentication methodology, which covers most of the world, and Mobile ID, which is supported by all the mobile operators. And recently, we've helped Switzerland, in the case of sort of Swiss Post, Swisscom 6, deploy a Swiss Trust Chain, which is a blockchain system for managing digital access, including currencies and medical records and so forth. Akoya, which we set up with Fidelity Investments and the 18 largest US banks, as a way of moving people's money around without sharing personal data. And of course, we're involved in the EU data regulations and auditing standards. So why am I talking so much about data? Because AI is built on data. AI really is just patterns in data. I think that's the best way to think about it. It's not magic. It's a process of discovering patterns of particular types. So it all comes down to data. How do you control the data? What data do you use? Is it biased? Who owns the data? what can you use it for? So there's ownership rights, which is where the discussion from GDPR and the California privacy law came from. And the notion of informed consent, because you can't have contracts between people. Yes, you can use my data for this unless you understand what's happening. And today we have these crazy EULAs, which are just nonsensical, and that will and is being replaced. And also there is this notion that data is a primary means of production, which means it is going to be regulated like money, like land, like labor. Also we're facing really increased cyber attack. As we roll out 5G and IoT, we increase the attack surface of our digital world. And it's expected that we'll get something like a factor of 10 increase in cyber attack over the next decade. So something really has to be done about that. And what we've developed is methods of doing this. Let's see if we can make this work. We're having troubles. Oh no. There we are. It's just taking a while. We've developed methods for doing this, which have been adopted in the EU by several of these large banking firms. It's something we call open algorithms, and it's based on federated data. So this is like federated AI. And the key idea is very sort of simple. It's that you don't move the data to the code. So you don't create data lakes and things like that, which involves having multiple copies of the data everywhere. That increases your attack surface. Also makes it very difficult to tell what's actually being done with the data, at least from the outside. And instead, you send code to the data. And there's only one copy of the data. It maintains control by the people that collected the data and are responsible for it. And this is, of course, federated AI. And we've seen all sorts of progress in this area. We've done lots of research in the area. The most interesting, perhaps profound thing is Google announcing that it's going to move to federated data like this for all of its Android systems. So, the idea there is data doesn't leave your phone. Instead, requests come and answers come back that don't reveal very much at all about who you are or your individual level data. And that is incredibly important in, of course, privacy, but also in security. From a programming point of view, let's see if we can, sorry, the clicker is being slow here. There we are. From a programming point of view, what happens is the system presents the identification and credentials together with a question to the person that has a data store. That could be your phone, could be your bank, could be your hospital. And they record the question and the credentials on a public ledger. Often this is a shared ledger, so like a distributed ledger, and that gets to this sort of blockchain idea. But the question is then evaluated locally on the local data. So recently, advances in federated learning have shown that this is at least as good in most cases as centralized learning, which is what almost all of the literature has been about. And it's actually much more efficient in certain ways. So it's got a lot of attractive things to it. So it's evaluated locally, it's posted on this shared ledger. And what's really interesting about this is that this is really cheap. You don't have to redo the semantics or the format or the model for all these different data sources. You just have to guarantee that the question, the algorithm that's run on it, yields an answer that has a well-defined semantics. So all this incredible cost of changing data models and redoing data so that you can make a data lake largely goes away. And importantly, the legal costs go away to a large extent also. And the way to understand that is if I come to you and say, will you give me all your data so I can do things on it? You'll say no, because you don't know what the risks are. You don't know really what I'm going to do. On the other hand, if I come to you and say, I'm going to send you some questions, here they are, they're open, and will you answer those, and I'll pay you a certain amount, you'll probably say yes, because you can now understand what's happening. And so the battle of the lawyers becomes much, much, much easier than it is in normal situations where you try to concentrate the data. So we've done this in a number of different places. We've done it with the US banks. It's been adopted by the EU as a standard for their systems. And clicker's being very slow here. Sorry. So maybe the gods here can advance to the next slide because this ain't working. Oh, there we are. There's something. So those are some of the people that use this sort of architecture. It's not unfamiliar out in the world. So when you come and provide a credit card to a merchant, it's not like they share all your details and your bank account with the merchant. What they do is they take that number as a routing number, which goes to your bank, and the MasterCard and Visa actually know very little about you or about your bank. They only have the routing and the amount. They know which bank to send it to. The bank then evaluates it without sharing your data, says yes, good, or no, not good. And then that comes back to the merchant, who doesn't know your bank account, doesn't know any of your details, just knows that the bank has vouched for you. So you can imagine now moving this to being able to do other sorts of data, like why not health data? So this is the sort of thing you're beginning to see with these vaccine passports, at least when they're done correctly. And you can imagine doing this with all sorts of data, and that's called digital identity. So the important thing is that you have multiple entities which are vouching for properties when you request it, but without sharing your data with anybody. And this is important for making business go in a variety of ways. So McKinsey, for instance, let's see if we can make this clicker go again. So McKinsey estimates that having this type of a system for authentication can add hugely to the GDP of countries. So this is perhaps the most easy thing you can do, and yet it's fought because there's a lot of people who make money off of this type of thing today that really wouldn't want to be put out of business. But yet you're beginning to see it spread. So many of the big firms like MasterCard, Visa offer these sorts of services. Many of the banks are going to this. Now, one of the things with this type of thing is that it offers complete auditability and real-time auditability. This is why your bank can say, hey, there's been a charge against your credit card that looks suspicious, and they can do that within seconds of when the charge is made and check with you. Today, most of the things that happen with data for AI, just maybe 6 months later, you find out what happened. Same thing with fraud and cyber attack. You always hear about, oh, the data was stolen 6 months ago. Why don't they know immediately? And it's because they don't have this sort of continuous auditability that these federated systems offer. So, this is now something that is likely to be required under new auditing standards. So you ought to pay attention to this, right? Just do federated stuff from the get-go with auditing. Similarly, this clicker is just not a good deal here. There we are, that got it. So one of the things it requires, of course, to move to this thing is federated learning. And there's been an enormous progress in this. This is a optimal, in the sense of minimum regret, decision-making system that we published in AMOS that allows you to make decisions without seeing people's data. And that's pretty mind-boggling if you think about it. So what that lets you do is make decisions. Oh, okay. I apologize. This clicker is just not working. Could you, the people who are listening, there we are. Okay. And one more click. Thank you. Oh, now it's all back. Let's see if we can get this to behave itself. So the importance of the federated learning that is differentially private like this is that now you can learn from data that you don't own, right? You're getting questions and answers. And in fact, you can learn even if the data is slightly corrupted or if someone's trying to scam you, you can still often get accurate answers. So that whole sort of data cleaning and certification and quality control becomes a much easier problem if you do it right in these federated contexts. So taking this to the next level, we're beginning to see what I call trust chains. And we helped Switzerland set up the Swiss trust chain. So it's a blockchain system using the IBM Hyperledger Fabric system. So it's very efficient and can handle tens of thousands of transactions a second. That's nothing like Bitcoin, for instance. But it has many of the same properties, is that it can handle medical data, financial things like that. And of course, this is the type of thing that will handle the new central bank digital currencies. For instance, EU is very, very close to announcing that they're going to have a digital EU. China has already announced that they have a digital currency. And many countries are doing this. For instance, we work with Singapore on launching their system. So this is for logistics chains, it's for all sorts of data. And the advantage is all of a sudden, all these different types of data are on a uniform platform where if you have the right permissions, you can look across the different categories of transactions, trade, tax, finance, etc., for fraud to make sure things are working okay, and things like that. And of course, the big, player in this at the moment is China. China has both a platform like this for their smart cities initiative and a digital currency that they're testing on only 150 million people. But China and Singapore together have something like $1.5 trillion of investment in the Indo-Pacific area. And you can bet that most of that investment, so those are banks, telcos, shipping, ports, are going to be moving to these sorts of systems in the near future. And that's going to be really revolutionary because now you can get uniform sorts of data across all these different categories for AI, for fraud detection, for other sort of purposes, given that you have the right sort of permissions. And as I explained, the right way to do this is through a question and answering system rather than just give me the permissions. So let's see. So one of the things that this course raises is, who controls all this data, who has access to it, who has the right sort of permissions. And one of the things we're seeing and we're working very hard on is to make sure that the data is held locally, that users, people, are in charge of their own data. And you'll hear the word data trust commonly nowadays, or data cooperative. The idea is that data is really just too complicated for somebody like me or you to really manage. We need somebody that is a fiduciary, a representative of us, to manage it. This is what we do with money. This is where banks came from. It was too complicated. We use banks to be able to hold our data. They don't own our money, right? So banks, we give them money, we can get the money back. They use it to manage it to get a safe return. We can do the same thing with data. So those are local entities that the users control, like cooperatives, like credit unions, and so forth. And we've focused a lot on a particular type of federated data, which uses these types of um, mechanisms to be able to run the entire sort of financial system. So we need these institutions to guarantee digital identity and ownership rights. We've talked about that, to audit. And banks are the answer for money. And what we need, of course, is we need data banks. So we're working with many institutions now to set up data banks where you would join a data bank, like you join a credit union, and it would help you manage your data. It would not own your data. It's helping you manage it. And one of the things it does is it allows you to get better services from the medical system, for instance. Today, you can't get the sort of, you can't go to your hospital and say, you're not giving us the right sort of service because you don't know what they're doing with everybody else. But if you had a data bank, all the members of the data bank could say, well, let's see if the hospital is doing a good job. Let's see if the city is doing a good job. Yes, you could probably get more money from it too, but that's actually not the most important thing at all. And what we see is this is a common thing. You have talked to many leadership groups, presidents, prime ministers and stuff, and you see this also things that are happening in the EU regulation, for instance, and as a consequence of the California privacy law. So look for these data trusts, data banks, data co-ops. You might ask, what do they actually do? Well, you're familiar with the census data, which is, how many people, what is the average income, things like that. What they don't show, though, is they don't show where people in a neighborhood work, where they shop, where they go to school. And that doesn't endanger individual rights, but what it does do is it gives you a sense of the flow of people within a community. And it turns out that you can use that in very many ways. The community can use those flow information to benefit the community. And so what we're doing is we're working to give much better tools for local entrepreneurs, for individuals to be able to invest their money and efforts in their community for better payoff. So this is an example of predicting growth in GDP in Beijing. Extremely accurate. We've done this in Europe. We've done it in Australia. We've done it in the US. It works. And what that means is you can tell what sort of stores are going to succeed if you open them. What are the investments you need in a community to be able to make the community thrive? And that's something we've never known before. And that sort of is transformative in terms of empowering communities to guide their way toward the future. If you're interested in all this stuff, of course, you probably want to read more. I have a new book, Building the New Economy, at MIT Press. It is free and online, at least for the next little while. There's the URL. Just Google New Economy Pentland and you can find it. It gives not only sort of the high level politics, regulation, and schemas, but also talks about the sort of more detailed infrastructure and AI for doing these types of things. So that's it. Thank you.
Thank you so much, Sandy. That was phenomenal.